Moving on now to the decode logic. So you've talked through the RISC-V instruction set with Kunal. Now we're going to implement all of the logic in hardware that's going to take this bit from memory, take this instruction from memory rather, and interpret all the bits as defined in the RISC-V ISA. All right, so the first thing we're going to interpret is which type of instruction do we have. So RISC-V defines these various instruction types, and based on those instruction types, the instruction will be divided into different fields. And in order to interpret those fields properly, we need to know what type of instruction we're dealing with. So the type in RISC-V is defined by the opcode field from bit 6 down to 0. The lower two bits, bit 0 and 1, are always 1 for the base instruction set. So we're going to ignore those two bits altogether. So we're decoding bits 6 down to 2, and I've expressed those in this table here. So if we're looking at a particular instruction, say this one, we want, we're in this box if instruction 6 and 5 are 0 and 1, and instruction bits 4 and 2 are 0, 1, 1. So we're going to define a bunch of signals that tell us, is this instruction a particular type? So I've started things off with this is-I instruction signal. The first line here is determining whether we fall into these two boxes here. I'm using this funny = question mark operator, which allows me to compare values that have don't cares, binary values that have don't cares. So this is saying if the 5 bits from 6 down to 2 are 0, 0, 0, 0, and then I don't care what the last bit is. So that gives me the 0, 0, 0, 0, 0 case and the 0, 0, 0, 0, 1 case. So this first expression takes care of these two boxes. Or the instruction opcode bits are 0, 0, again here, and 1x0, which covers the 1, 0, 0 and the 1, 1, 0 case. So these two boxes. And we have two more I cases. We have this case, and we also, according to the ISA, have this case, although none of our instructions actually fall into this bucket that we're going to worry about, so you can actually ignore this one. So you can add in the line that takes care of this box, and then you can subsequently add the various is such and such an instruction signal based on where the boxes land for those instructions. So go ahead, take your time with that. Be sure to get it right. Look in simulation at the waveform, at least for the instructions in our test program, and make sure everything looks good.